All right, hi, welcome. In this video, I'm going to go over the C++ standard template library. So this is the last topic in my data structures class usually. So, I mean, up to this point in the course, you've been learning how to kind of understand and write and implement data structures from scratch, okay? So, but you know, if you become a programmer, software developer, I mean, you wouldn't really be writing your own stacks and queues. I mean, you know, so it's very useful in terms of becoming a better programmer, a better developer, to have done that at least once, you know, to know, and you know, I think that really helps you understand kind of the issues and the trade-offs between performance and things. But of course, you know, if you're writing real production code, you want high quality industry standard kinds of containers for to use that have been developed by professionals and tested by professionals, you know, and you know, all the kinks and bugs have been worked out of. So that's really what the C++ standard template library gives you. And in fact, I mean, my experience, most people seem to, you know, not like C++ a lot because they think it's a lot lower level of a language. But once you use the standard template libraries, it really makes C++, to me, I mean, it is as high level as equivalent to like Java, maybe not up there with like Python or R or a real high level language like that, you know. There's still a little bit of cruftiness, so I do think Java is a little bit better still in terms of some implementations for containers and things, but really there's a lot of similarity, okay, in anything you can do with like Java at a high level or abstraction, you can do with C++ if you learn and use the C++ standard template libraries, okay? So anyway, I'm just going to go quickly through a couple of these just to give you a flavor of these, okay? So, I mean, again, if you followed the stuff in this course up to this point, these should make sense to you now, you know. So another thing that's really useful about this course is you've got the backgrounds about what templates are, and kind of what the data structures like stacks and queues are, these containers, and what it means to iterate over containers, okay? So now with all that knowledge, you should really be set now to be able to really, you know, understand and use the containers and the other parts of the standard template library, all right? So I'm going to look over a couple containers. So we're going to look at stacks and queues and priority queues in the standard template library. We'll also look at maps, which are the implementation of the key-value pair. So we talked a little bit in this course about dictionaries and hash tables. So another name for key-value pairs other than dictionaries are maps. So the standard template library has maps. And we'll look at iterators, so using iterators in standard template library, and then real quickly, last thing I wanted to look at algorithms. So the standard template library isn't just data structures, stacks and queues. It also contains other things like algorithms. So basically, we'll just look at the sorting algorithm. There's a lot more stuff in there, but we'll look at doing sorting with the standard template library. All right. So as usual. I will make certain that this code file is available with the video in our class site. All right. So let's start off with the basic stacks and queues. Okay. So the standard template library has they're called container adapters, and again, that confuses people sometimes. What that means is that really the stack and the queue and the dequeue, the deck, the double-ended queue, and the others, they're really built on top of more basic containers. So if you define a stack of doubles, you're probably actually using a vector or maybe a list underneath. You really don't care. It picks the right container that has the best performance for what you want to do, for a stack in this case, all right? So let's just look at a stack. So notice, you know, so all the things in the standard template library, as the name would imply, are templatized. So if I want to have a stack, I have to say what of the items the stack is going to hold. So in this case, we're just going to hold a stack of doubles. Okay. So if I want to declare a stack like this, I need to include stack for the standard template library. It's just a stack. Excuse me. all the rest, most of these are also standard template libraries. If I want to have a standard template library list, I just include lists. Maps are for the standard template library, vector, and so on. Okay. So anyway, so we're going to use a stack here. Oops, went past it. So, I should have had this website open here. Let's see if this comes up relatively quickly. So, I still think C++.com is basically a good reference. You know, so if you need something that will work as a reference for standard template library containers, you can go here. Some people prefer CPPReference.com. So you might have seen me use this before. You know, if you bring that up, over here to the reference, you can go to the various parts. Like if you want to go to the algorithms, you would want to go to other, but most of the stuff is in the containers here. So this is where you can go to in order to find, you know, information about stacks, queues, maps, decks, vectors, and things like that. So we're working with the stack here. So the reason why I wanted to point out this reference is if you need to know, you know, I'm not going to cover everything, but if you need to know all the different methods that you can invoke against a standard template library container, you'll need a reference like this. So we're only going to look at some of the basics, but here are kind of the basic member functions that you can invoke for a stack. So you can ask for the size, you can push onto the stack, you can get the top item off the stack, you can pop off the stack, and so on. Okay, so notice it's really a fairly small basic set, but these are pretty similar, pretty close to the abstract data type for a stack that we implemented and looked at in this class. So pop and push and top and size to get the size. Okay. All right. So let's go back here. So look at the stack. So if we wanted to, you know, push some items. So I've got a stack of doubles. I push 3 items on here. So notice I push 4.5 first. So after the end of pushing all 3 of these items, remember 4.5 is going to be on the bottom of the stack, and 42 will be at the top of the stack, right? So let me go ahead and run this and get to here. So oh, I didn't execute that. So just some examples, some of the other things. So empty is a member function you can call for stacks. So it returns true if the stack is empty and false otherwise. So here, once we run that, we see that the stack is not empty anymore. There's 3 items on there. So we can ask like which items are on there. Let me go ahead and go all the way down to here. Let's run it down to that point. Okay. So we could ask for the stack size. So the size is 3 here. We can use top to get the top item. Top is 42, and then we can pop an item, and so on. Okay. So yeah, won't go into those in any more detail, but this is the same. You know, the method names might be a little bit different from the abstract data type that we defined in this class, but it's a stack like we use. It's an implementation of a stack. We can have a queue. So a queue implements a first in, first out. So the basic things for a queue. It has push and pop as well. So I can't remember if we called it enqueue and dequeue or push and pop in class. But basically for a queue, if you push, it's going to push onto the back of the queue, and if you pop, it'll pop from the front of the queue, right? And you can ask for the front to see the front item. And so these are basically kind of the same member functions that you can work with a queue, but it's a first in, first out instead of a first in, last out, which is, you know, your stack. Okay. So let's go ahead and run those down to there. So there. You can try those on your own, right? But those, you know, that gives you your basic stack and queue. One of our assignments, we used a priority queue. So the standard template library has defines priority queues, which are useful in lots of different situations in computer science and software development. So actually, priority queues are in the queue header, so you don't have to include something. You don't have to include priority queue. There's just include queue to get queue container adapters and to get priority queue container adapters. All right. So the default behavior is kind of the same thing for the priority queue that we implemented in one of our assignments. So it uses the less than operator by default in order to arrange the item. So if I create a priority queue of integers and I push some integers on there, and here we iterate over, we're not using what's known as a STL iterator, we're just checking, so as long as my priority queue isn't empty, we peek at the top item to display it, and we pop it off. So in this case, we push all these items on there. But so before I tell the answer, what do you expect to be the output from running this, right? So we're pushing 4 items onto the priority queue, and then we pop all 4 items off in this while loop, right? So if you understand what a priority queue does, the default behavior is to put the highest priority item at the top. And since it's using less than, the highest priority item for integers is just going to be the largest integer. So 100 should come off first, followed by 40, 30, and then 25, right? So that's indeed what you see. So that in that while loop, this output came from the execution of that while loop, so iterating and taking the items off of the priority queue that we had pushed on there. So we first got the highest priority item out when we peeked at the first item, and then the next highest, and so on. All right. So that's our priority queue. So like we did in our assignment for priority queues, here's our first example of using standard template library for a user-defined class instead of like a built-in type, like an integer or double. So if we have a simple employee, so that's up at the top here, similar to some employees that we've used for examples and for testing and assignments. So employee has a couple of attributes like a name and an ID and a salary. Has some constructors. It has some accessor methods to like get the salary. I overrode the less than operator to compare. In this case, it compares by employee ID. Okay. So an employee with a smaller ID is going to be considered a smaller or less than an employer with a bigger ID because of how I implemented and overrode the less than operator here, right? So let's look at that then. So here we push some employees onto the priority queue. So again, this is a priority queue, and since by default it's going to be using the less than operator only to figure out the priority of these. So it's going to use the ID since I defined operator less than for my employee. So if I do the same thing, push 4 employees in this case, and then have a while loop that pops them all off, we should expect them to come out again by priority order. But priority is based on the ID, the employee ID, which is the second value of the constructor here. So the one with the highest employee ID is John Student, so that one we would expect to come off first, followed by Susie Employee, and so forth, right? So if you look at the output, so you see the first one that comes off of the priority queue of employees is John Student with an ID of 7, and then 6, 5, and 3. All right. And then real quickly, so sometimes you need priority queues for like a user-defined object like employee, but you need different priority queues. So you might need one priority queue ordered by employee ID, like we did here, but I might need a second one ordered by salary, which is what I do on the second example here. But I can only define one less than operator, so I can only overload operator less than one time for the class. So you're stuck unless you have to do something slightly different. So instead, for priority queues, you can pass in additional parameters when you construct your priority queue. So the third one here, you can pass in what's known as a comparison class, or you can also just use simple functions as well for this. But this, so instead of using the less than operator, if you pass in a comparison class, it will use that instead in order to do the comparisons and to figure out which is higher priority and which is lower priority, right? So here, again, if you look up at the top for this, in this case, this is an example of the whole class. So the employee salary comparison class has one function, which is an overloading of just kind of a null operator. That's the way this works for this comparison class here. this expects to have 2 employees, and here, and then we just implement less than on the salary. So that's how we define an ordering on salary now instead of ID, using this comparison class here, right? So yeah, if we do this one, so again, we're basically doing the same thing, but I'm using this comparison class to order by salary. So you should expect the highest salary to come out first from the priority queue. So Susie, employee, with a salary of 58, followed by me, 42, and then 38 and 15. Right? So indeed, that's what we get. So highest salary came out first from the priority queue, followed by second highest salary, and so on. All right. All right. So those were the container adapters. We looked at stack and queue and priority queue. Those are, basically those are the basic ones, and you get a lot of use out of those. So you need those in lots of places. There is no kind of container adapter for trees, so there isn't really a binary tree in the standard template library, although that's not really true. So map actually uses a binary tree instead of a hash table, so I'll talk about that when we get to map here real quickly. So the items we just looked at are known as container adapters. There are other containers which are mostly used as to hold or to sequence items. So these are often referred to as sequence containers. So the most basic of these are vector and list and dequeue, which is what our textbook in the appendix talks mostly about these 3 here. What's the difference of these? So again, from taking this class, now you can kind of maybe better appreciate the difference of these. So really, I mean, again, you can use these to basically do the same thing. It's just it's a matter of efficiency. Okay, so vector and dex, or vector and double-ended queues, underneath they actually use an array-based implementation. So if you remember back, we discussed, like for linked lists, array-based versus linked list-based implementations. So for an array-based, so for example, if I need to add items onto the end, or if I need to access items in the middle, since arrays are random access, it's an order 1 operation to do a search and find an item in the middle. So lists and dex, insertion at the beginning and the end, or searching for items are order 1 operations, because it's using an array underneath. But if I want to insert a new item in the middle, it becomes an order in operation, because since it's an array, and it keeps them ordered. It keeps the list ordered by however you insert them in there. So if I want to insert something in the middle, I have to shift items in the array, right? So to make room for it, right? So the list then, though, uses a linked list implementation rather than an array-based implementation. So remember, the main advantage for a list then is that it's going to be order in to do a search still, because you have to do like a linear search to find items in the middle. The only real advantage for the list is that you're guaranteed that if I need to insert an item in the middle, you're guaranteed that the main advantage for the list, for the linked list, is that if it's very dynamic, if you keep adding lots and lots of items, it always just is an order 1 operation to add a new item to like the beginning or the end. But for the vector or the deck, it has an array, so it has a size. If you fill it up and you add one more item, it has to do like what we showed in this class. You have to reallocate a new array that's of bigger size and then copy all the items over there. All right. So that's the main difference between the vector and the list in the standard template library. So anyway, so you can use these to do things like So really, if you have been using C++ and you've been using just basic arrays, you really shouldn't use basic arrays anymore, because the standard template library containers like vectors or lists are safer. Okay, so they protect you from doing invalid memory accesses that might corrupt your memory or things like that. Okay, so really, instead of using regular arrays, like an array of integers, you really should be using like vectors or lists to be safe. Okay, so let's just show a vector, some operations on it. So we can create a vector of integers. In this case, we specify the initial capacity up front, so it'll hold up to 5 items before it has to grow. Okay, so initially its capacity is 5. And it is initially so notice it initializes the 5 items to have values of 0, so it doesn't consider it to be empty initially, which is a little bit bad. So I don't really like that behavior. But yeah, I mean, even initially, before I like push some items on there or assign some items in there, and to consider non-empty, it's just initialized all the values to 0. Okay, and notice it has the size of 5, right? So when we specified that we wanted a capacity of 5. Okay, so anyway, vectors you often use as replacements for arrays, right? So if I want to assign the items, I can use array indexing notation, right? And the vector standard template library does the right thing. So here we'll assign the squares of the indexes to the items. So you can use that both for assignment and to read the values back out at particular locations, right? So so if we do that and we read them back out, we see that 0 has 0, 1 has 1 squared, 2 has 2 squared, or 4, and so on, right? Okay, and that's basically, so I didn't show a list or a deck, but they have the same kind of methods. So if we go in here and look for like the methods for like a list or a vector, they mostly overlap in terms of the member function. So you can push and pop on the back, push and pop on the front. I think for a vector you can't really push on the back, but for a deck, a double-ended queue, you can push on the front or the back, and you can do that for a list as well. So the list is actually a doubly linked list, so it's efficient to push on the front or the back. You can size, resize, clear it out, so remove all the items, that kind of thing. Notice that a list, you can sort a list. You can't do that with vectors or with decks, so I'll show that later on as well. Okay, so then that was mostly the things about containers and about container adapters. So now I want to talk a little bit about iterators in the standard template library. Okay, so we briefly showed creating our own iterator in one of our assignments in this class. So the syntax for what I think of as the original or old style iterators in the standard template library looks similar to what we did when we did it by hand in this class. Okay, so you define an iterator object, so an iterator over a vector of int. So you do this vector int : iterator. And you initialize it if you want to iterate from the beginning to the end. You initialize at the beginning, so called the begin method. You check whether you're at the end or not of the iterator, and you increment. And you should do a pre-increment. Doing a post-increment has problems, so you'll see all examples use ++ iterator, ++ it. So it does it in a pre-incremented way. But anyway, so notice we did the for loop to get all the values out of there. So here was an example of using one of these original standard template library style iterators to do the same thing, to access the values. Another thing, so these iterators are a little bit crufty, so this IT object is actually a pointer to, in this case, since I have a vector of ints, it's going to be a pointer to an integer. So you have to dereference it in order to actually get the value of the integer. Okay. So anyway, if you do that, though, you can iterate and access all the values in my vector of ints using this iterator. So we get those values again, 0, 1, 4, 9, and 16. Okay. This is relatively recent. I've shown these before in this class. These are known as range-based iterators. Okay, so now you can do something to me that looks much more cleaner and looks much more like Python code, the way you'll see iteration done in Python or R or other much higher level languages. So I've begun using these pretty much exclusively rather than using these original style STL iterators. Okay, so if I want to iterate over my vector of ints, I can say auto num. So auto is just a keyword that basically it figures out what the type of num should be based on the type that the container holds. So since this is a vector of integers, it figures out that num should be an integer. And then each time iterating through the loop, num takes one of the values from the container. So num will actually hold. It'll be an integer holding the value. So notice I don't have to dereference num like I had to dereference the iterator here. I can just directly access that and display it. All right. So that to me, that's much more readable. This is just for number takes on each value in my vector of ints, and then I can do something with each value as I iterate over my vector of integers here. Right. So again, we should get the same values coming out of my vector of int here. All right. All right. So. So real quickly then, these containers like vectors and lists, though, they are safe. They're memory safe. Okay, so if you keep adding items onto like a vector of integers, even though its capacity was only a size 5, it will grow the container so it can hold more items. So if I push another item onto the back of my vector of integers, you'll see that it doesn't crash or anything. It just grows the container. So now the container had a capacity of 5 before, so after I pushed the 6th item, it grew from 5 to a capacity of 7 for some reason, right? And now if I push in some more items, 7, 8, 9, 10, 11, stop there. So after pushing the 11th item, it has a capacity of 15. So it grows the size. I don't know exactly what the algorithm is. So I thought it usually doubled the size, but it actually didn't do that this time. It just increased the size by 2 when I added one item. But yeah, at this point, when we got up to 11, at some point, so even though there's only 11 items currently in there, the capacity is size 15, and so on, right? But anyway, that's looking. You don't usually have to worry about what the capacity is. So again, the containers, the lists, and the vectors, and the deck, they do all that for you. They keep the size correct. Okay. All right. So that's the basic sequence containers. Let's look at the map container. Okay. So. One of the things that we did in this class, we looked at dictionaries or key value pairs. The standard template library has what are known as map containers, which are basically the implementation of the key value pairs. So if you go down here and look at map, so there's others like multi-map and sets and things. But map is your basic key value pair. Now, as I said, because of for reasons that I won't go into, it's tough to implement a general hashing function in C++. So really, the maps or the dictionaries actually are implemented behind the scenes as binary search trees. Okay, so maps define a key value mapping, but behind the scenes they're actually using the tree, a tree data structure. So you expect that both insertion and search are relatively good performance. It's not order one, so since it's not using hashing, insertion isn't and search isn't order one on average, but it's log n, so it's still pretty good, right? So here's your basic way to create. So notice when you do a map, you give two types. So the first one is the key. So I'm going to use strings as my key and employees as my value. So I'll just use the employee name to index or to key into my key value pairs for my mapping here. So notice, so here's how you can assign. This is a basic way. So if I want to assign for the key Derek Harder an employee, I create a new employee and assign it the mapping between the key Derek Harder and this employee record. All right. So all these are assigned the mapping between the string and the employee record. All right. So after we do that, let's stop there. So after we do that, there should be 4 items in the dictionary, in the map. So indeed, the size was 4. And here I show an example of iterating over the dictionary. Okay, so if you use the original iterator, you can do the same thing to iterate over the dictionary. Now, a dictionary, so in lots of high-level languages, if you iterate over a dictionary, since it uses a hash table or a hashing behind the scenes, when you iterate over, the keys come out in a random order, so you can't specify the order. But it's different for the standard template library map. So since it's using a binary search tree, whenever you iterate over the items of your map, it comes out in sorted order, sorted by your key. Okay, so in this case, if I iterate over using a standard template library iterator, so notice I have to use, notice what you get out in this iterator is you get a key value object. Okay, so this key value object has 2 fields, a first field and a second field. So I don't like the names here. It would have been better if they called this key and value for the field names. But basically first is going to be the key of the key value pair, and second is going to be the value of the key value pair. So if you iterate over these, the first, and if I display these, the key I can get from accessing the first member field, and the value I can get from accessing the second member field. So, and you'll notice this should come out in sorted order, but yeah, it's sorting by the first name. It's just sorting by the whole string. So I first get the D, and then I get the JA, followed by the JO, followed by the S, right? But yeah, but we can iterate over. And you can actually use the range-based iterator. So again, I think this is cleaner. But again, what you get out is you get one of these key value pair objects. So you have to use and again, it's not a pointer. It's an actual reference to a key value object. So I have to use pair.first to get the key and pair.second to get the value. Okay, but I can do the same thing to iterate over my mapping in this case. So and it comes out in the same sorted order again. All right. So I only showed using this to assign values into the mapping, but I can also use that the same index operator to search as well. So if I want to read out based on the key, I can find the record associated with the Derek Harder key and display it, and I can find the record associated with the John Student key and display it. Okay, by accessing the mapping like this. All right, so that works to get those 2 employee records that are associated with the 2 keys that I searched by here. All right, so that was basically the. We went over, the sequence the containers and the sequence containers and the iterators and the maps. So the final thing, let's look at the algorithms in the standard template library. Okay, so I'm going to look at all these. So again, on C++.com, if you want to look at the algorithms, you have to go. You can go down here to like the miscellaneous headers. Oops, I don't know why it's doing that, but yeah, here they are. And we can look in. There we go. There's lots of other things, but we can look in, for example, in the algorithm header, and so these are all the other kinds of things that you can do. So fill and swap and copy and things, but probably sorting is the most useful in here. So let's look at sorting. So it's easiest to use the STL algorithms on STL containers. Okay, so it's straightforward. Oh, so as I already mentioned, list. I don't think like the deck or the vector you can sort, but list you can. So if you need to do a lot of sorting, one obvious thing to do is just to use lists, and then you can call sort on list. So if I create a list of all these values, so this initializes the list to have these 10 or however many values. And if I sort, call sort here, and then if I iterate over the list, yeah, this is the result from sort. So the default behavior again is to sort by using the less than comparison operator, less than, greater than, and equal to. So, and by defaults, the sort function will do an ascending sort. So you'll get the smallest item first in my list now. This actually sorted the list in place. So the list is sorted now in place here. So 3 is now the first item in the list, followed by 5, 6, 8, and so on. Right? Okay, but you can sort vectors and DQs if you need to. I think you don't have a sort method. I could be wrong on that. I should check that. But here's an example though of using the sort algorithm from the standard template library algorithms. So again, to do this, you have to include the algorithm header to get the sort function, the sort algorithm from there. So if I have a vector of doubles of these values, so the way sort works is you have to give it an iterator. Okay, so if I want to sort my whole vector, I just pass it begin and end, the begin of the iterator and the end iterator, and it'll sort the whole thing. But again, it sorts the vector in place. Okay, so after calling this, my doubles is now sorted. So if I iterate over my doubles, you'll see it goes from the small, again it sorts in ascending order from 1.2 smallest to 9.1 the largest. All right. Another example. So if I want to sort, in descending order from the largest to the smallest, I have to pass in a comparison function or a comparison object. Okay, so here in this case, I give an example of using a simple function here. So if you look back at the top for the function called compare double reverse, here it's just a function that takes two doubles and returns a Boolean result. It uses greater than rather than less than to compare the two doubles that are passed into it. That's all you need to do then to do an ascending sort here. So the second sort will resort my doubles vector, but in ascending order. And then if we iterate over my doubles vector, you'll see that it's now sorted in descending order from the largest down to the smallest. All right. All right, so yeah, that was really quick, and that was only kind of the basics. So as you kind of saw when I brought up the reference, there's a lot more in the standard template library. But if you know the basics of using like stacks and queues and maps, and how to do some sorting and things like that, and how to iterate over things. That'll get you a long way to really being able to improve your game and code C++ at a much higher level, you know, so which makes it much easier to tackle large or more complex problems. All right. Anyway, so that's it for today. That's the basics of the standard template library. I hope that is useful for you, and that helps you to better understand how you can use this basic functionality of the C++ language. And I will end there for this video. Thank you.